today I am making a quick video about integration by parts. I'll be covering the basic derivation of the parts formula, a cool YouTube trick I learned from Math BFF, and I will also cover 2 examples from the textbook. Also, I will go through when to use integration by parts, and I'll add some tips that helped me grasp concepts throughout. Okay, let's get started. Where did the integration by parts formula come from? Well, watch out, there is some cool math ahead. This formula comes straight from the product rule from basic calculus. Don't mind the typo in this picture, let's all just pretend it says product instead of chain. Alright, so the product rule is applied when you are trying to take the derivative of 2 functions multiplied together. In this case, we are wanting to find out the derivative of f of x times g of x, so we will apply the product rule. The product rule tells us to take the derivative of the first function multiplied by the second function as written and add the first function as written times the derivative of the second. At this point, since we are in Calc 2, we are allowed to get creative, so let's take some integrals. The initial derivative will cancel out on the left side, leaving the original functions, and an expanded derivative is left on the right-hand side. The next step is to subtract f prime of x times g of x dx, the integral, from the right-hand side and move it over to the opposite side. At this point, this is exactly what our integration by parts formula is, just written in a different form, so let's use some substitution to make it look the same. So let's let u equal f of x and v equal g of x. That means the derivative of u is going to be f prime of x dx, and the derivative of v is going to be g prime of x dx. We can use those letters to substitute down, and we move that equation around, and we have our integration by parts. Now that we've covered the derivation of the formula, let's get into some details about how and when to use this strategy. Legend has it that the hardest part of this technique is determining what you will be. Well, fret no more, enter Liate. It sounds pretty funny, but it's useful. This mnemonic device can be used to determine what you should be in a problem. Starting with logs, you go through each letter until you find one of the defined terms in your problem. Feel free to pause here to write this down. Liate is super useful, but it's always good to double check and make sure that your u will ultimately become simpler when we take the derivative. So how do we know when to integrate by parts? Well, the guideline is to use parts when you are taking the integral of a function times a function. And what does that look like, you ask? Like these. In my mind, I can see how each of those, if graphed, will produce some kind of line, and when we are finding the area under those lines or curves, we are using parts to separate things to make them a little easier to handle. Cruising right on through, let's get into some examples. For example 1, we have the integral of x times cosine of 5x dx. We have our tips and tricks up in the corner, so let's set this up. First, we need to figure out what u is using Liate. Are there any logs? No. Inverse trig functions? No. But we do have an algebraic x all alone, so we can double check that it'll get easier after we take the derivative, and yes, x just becomes plain old dx. Awesome. Next, everything that is left over in our integral, which is cosine 5x dx, becomes dv. The problem has a little bit extra in here, so let's take a closer look at how I integrated dv. I used u sub to substitute for the 5x, and du equals 5 dx. Shuffle it around a bit to make it a little easier to work with, and dx becomes du over 5. We're going to plug that back into the function, and we get the integral of cosine u times du over 5. We'll pull out the constant, and we're left with 1/5 times sine of 5x. Now let's zoom back out, and we'll put that into our previous variables, and we have everything we need to start integrating. Using the variables we determined, we can now plug into the standard parts formula. Based on that formula, we have 1 over 5 x sine x, or sine 5x minus, and we're going to pull out the 1/5 times the integral of sine 5x dx. After the integral, that becomes 1 over 5x times sine of 5x minus 1/5 times the negative cosine of 5x over 5. We're going to do some quick algebra, and we end up with the answer 1/5 x sine 5x plus cosine 5x over 25 plus c, because it's an indefinite integral, and you usually get a point for that on a test for just remembering it. One example down, let's get into number 2. So for example 2, we have the integral of x times e of x dx. In the corner we have our tips and tricks. We are going to determine u, and in this case we have an algebraic function, which is x, and x does get simpler, so we're going to use x as u, and our dv is going to be e to the x dx, making our v just e to the x, because that's a really easy one. So we're going to plug all of that into the formula, and we end up with our initial integral equal to x times e to the x minus the integral of e to the x dx. So after we use just the basic integration techniques, e to the x is still e to the x, so we'll end up with x times e to the x minus e to the x plus c, because again it's an indefinite. So I know I said I only had 2 examples, but let's try one more. We'll call this one a bonus one. This integral is going to be the integral of ln of x dx, mostly because I just wanted to use the L in Liate. So our u is going to be ln of x, making our dv just dx. Kind of weird, kind of cool. So du is going to be 1 over x dx, or dx over x. Next, our dv dx is going to, like when we add 1 to the power divided by a new power, it's going to just leave us with an x. Next, we'll plug all of those variables into the parts formula, and we will get x times ln of x minus the integral of x times dx over x. Something kind of cool. The x's cancel, so we are left with x times ln of x minus the integral of dx, which, as we know, add 1 to the power divided by a new power, we are going to be left with x ln of x minus x plus c.